Hi guys, hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. So today we're going to look at the concept in dividing complex numbers, and this is going to be specifically an illustration using the polar form or polar representation of complex numbers. Now we said that we can be able to represent complex numbers in two forms, whereby we are going to have the face of z represented as x plus I. Why? So from the Gandhi diagram, I'd given an illustration of this representation for the rectangular form, whereby we said that they can be given as a stretch along the x axis for the real numbers, and then the y-axis for representation of an imaginary part. So this therefore is a rectangular form, and we can be able to give this particular representation in polar form in terms of r theta, or this one can as well be given in terms of r. So this the face z is given as r, and then the angle theta given as such. So I'm going to use this particular second form in trying to represent or do a division of complex numbers. And therefore, if we are going to be given two phasors for r, z1 and z2 given as such, we can be able to have a general representation for this specific two phasors by having this z1 represented as r1, and then this is going to be theta 1 given as that, and then the phasor z2 represented as r2, theta 2 given as such. So for me to divide these two specific numbers, I'm going to divide the two complex numbers by dividing their moduli, and then we are going to subtract their argument using this specific format. So suppose we have an example of a specific example, we can be able to give a general representation for division of phasor z1 and phasor z2, and of course this is going to be given as r1, this is going to be theta 1, and over r2, and this is going to be theta 2 given as such. So this therefore is going to imply that we're going to have r1 over r2, and then we're going to have this theta 1 minus theta 2 given as such. So suppose we have an example, or we can be able to give a specific example for this. If we have z out of the phasor 1 represented as 33.9 degrees, and then phasor 2 represented as 3, and then this theta is 23.6 degrees. We are going to consider the division of these two specific polar representations of complex numbers. So therefore we are going to have it given as phasor z1, phasor 2 given as such, and then we are going to have this one as. So we have said that the strategy that we are going to use to achieve this is to divide their complex numbers by dividing their moduli. The moduli for z, the phasor 1 is given as 5, and the moduli for phasor 2, the modulus for phasor 2 is given as 3. So this is going to be a ratio of 5 over 3, and then we are going to have it given us the difference between the angles for theta 1, 33.9, minus theta 2, which is 23.6, and this is going to give us the value of 1.67, and then theta is going to be 57.5 given as such. So we can as well decide to give this one in terms of radians, whereby we are going to have it represented as 1.67, and then the angle, this is going to be 23 over 72 pi. So we can be able to check this one to ascertain the specific value, so that we are able to confirm or maybe sure over this specific answer that I'm getting. So generally this is how we're going to perform a division of complex numbers, by giving it in terms or by dividing their moduli for r1 and r2, and then subtracting their argument, which is for theta 1 and theta 2 are given as such. So catch us in our next videos. We're going to look at a different way of performing operation on complex numbers, and that is going to of course complement on this specific video. Kindly check in our description boxes for various links of other videos which are going to be similar. So that is it for now guys. Bye, God bless.